In this tutorial, you will learn how to construct an implant guide with an open skeleton design. This option is found directly below the closed frame option. To begin, look for a suitable starting point on the surface of the model. We will place the cursor over here, shift and right-click. Navigate to the menu, and press the Draw Frame tab. Immediately the blocked-out model will appear. To recall, this model is comprised of an offset model, with all its undercuts removed. This is a crucial component, since this model is used to create the inner fitting surface of the skeleton guide. Our goal is to design a guide which fits passively into the mouth without having to adjust it. Notice the sphere, which has been placed into the location of the cursor. By clicking the E key, you can extrude the sphere. Here you will see the extrusion in real time. From here on, we will refer to the extrusion as the line, since essentially, we are drawing a line which represents the guide frame. The line is seeking an ideal position on the underlying mesh to adhere to. By left-clicking you can set down the line. In the upper part of the 3D working window, notice how the magnet tool has been invoked. This means that the extrusion will adhere to the closest surface. The closest surface is defined by a preset value of 2 mm. This value is displayed in the slider bar on the menu, over here. You can change the frame offset value anytime. For this demonstration, we will keep the value set to 2 mm. You can now select a vertex, and by using the G key, you can freely move the line. Since the magnet tool invokes the line to adhere to the blocked-out model, it is best to place the line close to the surface of the model. We will position the line close to the lower section of the guide sleeve. Press E to extrude the line, left-click to set it down. Always consider the best point of placement. Here, for example, if you were to position the line in the blue area, the finished frame would sit away from the tooth surface, due to the nature of the undercut. As a general rule, place the line on, or near, the survey line. This is the upper junction, between the white area and the green area. Press E to extrude the line. Place one vertex on each tooth. Continue this way, try and follow the survey line. As you have learned in the previous tutorial, we do not advise traveling through the interproximal embrasure area of the teeth when looping the frame back into the other direction. It is better to move up and directly over the midline of the tooth. We do this to avoid the complex mesh arrangement, which makes up the deep crevice of the interproximal embrasure. This also means easier printing of flat surfaces, rather than deep embrasures, which may cause obstructions preventing the frame from correctly seating in the mouth. Move from one simple and flat surface to the other. If you would like to set the thickness of the frame, press the letter A on your keyboard. This will select all the vertices along the line of the frame, then press Ctrl A. By moving the mouse, you will be able to scale the diameter of the frame. If you would like to scale one specific area, you can do this too. This time, only select one vertex in the line, and by pressing Ctrl A, you can scale just that section of the line. You can make it thicker, or thinner, left-click to set down the line. Continue to extrude the line. We will fast-forward this section. When you get to the other side, you will need to fuse the two ends. In order to make the vertices more visible, we will have to offset the line into the midsection of the frame. To do this, navigate to the menu, and check the small box which says, On Frame. This will immediately center the line away from the surface of the model, and relocate it into the midsection of the frame, as can be seen here. This makes it easier to find the starting vertex, and the end vertex, so you can join the line. Shift left-click on the other vertex, to select both, then press F, to fuse the line. We will now focus on designing some lateral support, or crossbars required for the frame. For example, we can create a crossbar between the two guide sleeves, buccolingually. Since the buccal vertices are spaced out in such a way that we cannot access a suitable vertex to extrude, we have to create another vertex between these two vertices over here. To do this, select the vertex to the left, then shift left-click to select the vertex to the right. This will select both vertices. Make sure you have a double selection, go to the menu and press on the plus sign. This will add a vertex in between the two selected ones. On the other side, there is already a suitable vertex to join onto. Left-click to select this one, then shift left-click to select the other. Press F on the keyboard. This will create a new edge, and join the two together. Likewise, here, we can move over the occlusal surface. Select this vertex, then press E to extrude. Left-click to set down the line. Shift left-click the other side, then press F to fuse the line. Continue, and repeat the procedure, to add more lateral support structures to the frame. The guide should be well supported, over the occlusal surface. Again, avoid the embrasures, and rather construct the joins, over the midsection of the teeth. We will design one more support structure, over here. Here, since we have gone into the embrasure, select the vertex and use the G key, to relocate it. Please note that, at this stage, there are overlapping vertices in the mesh, especially in the areas where the crossbars meet the main part of the frame. In order to maintain the integrity of the mesh, we will have to rectify this situation. To view the mesh, go to the menu, and place a tick into the display wire checkbox. Here, you can see the problem with the overlapping vertices. In order to reconfigure the geometry of the mesh, click on one of the vertices in the area. Then use the G key, to grab it. By moving the mouse, you can untangle the mesh from a tense-like structure, into a more relaxed kind of state. You will see it unwinding, in real time. When the mesh has a more uniform structure, just left-click to set it down. We will need to repeat this process, on all the other adjoining areas. Please remember, a clean and organized mesh structure, is easier to slice and to print. Use G, and move the mesh until it becomes relaxed. Something like this. Inspect the frame. We can still extend an area over here. Since there is no vertex in this area, we will select a vertex, shift left click on another, and by using the plus sign, we will place another vertex into the middle. Select it, then use the G key to relocate it to an ideal position. Now press the E key, to extrude. Shift left click, to select the other side, then press F, to fuse the line. You can add more support, by selecting a vertex, then use the E key. You can use the Alt and the A key, to make this section thinner, for example, if you want to create an occlusal rest. If you would like to add more lateral support, simply select another vertex here, then the other, on the opposite side. Press F, to fuse the line. Then, place the mesh into a more relaxed state. Something like this. There are many possibilities for your design. Continue to readjust the joins, until you are satisfied with the outcome of the frame. Double-check the frame, to see that the attaching surfaces are adequate. If you need to increase the contacting areas, you can use the frame offset slider bar, on the menu. By entering a new value, or by moving the slider, you can move the frame closer to the model. After this, we can solidify the guide. Navigate back to the menu, and press on the Complete Skeleton tab. This action will remesh the entire structure into a brand new mesh. You can now select it. This will reveal an orange wireframe. Move to the menu, and uncheck the Display Wire checkbox. This has completed the skeleton frame. With this, we will complete the tutorial. In the next tutorial you will learn how to trim the guide sleeves, and how to clean away the intersecting mesh on some of the inner components. Thank you for watching this video.